Hello, and I'm excited to talk to you today about securing microservices on zero trust networks using API gateways. Oops. So just to set the stage, usually we're talking to customers who are looking or somewhere on their journey towards microservices. Now, as people moved away from monoliths towards microservices, it brought a lot of advantages. It led to increased productivity, allowing multiple different teams to move in parallel on different parts of an application. It led to and enforced good software design principles, and it was flexible and encapsulated knowledge effectively across an organization. But it did create challenges. So the first challenge is obvious. More dependencies, there's more services to deploy as part of an application now. Applications are just more complex. And as a request spans multiple hops, there's performance considerations around latency and other issues. It's more costly and more difficult to manage and maintain these applications. And as you start to develop many services that have different interactions, it can be pretty difficult to actually test end-to-end that everything is working in a representative way. Another way of looking at this, so in the old monolith world, you kind of had a single box here on the left where you have users interacting with some UI or some client tool, do some business logic, hit the data layer, but this would all really be contained inside of a single process, and thinking about security was fairly easy. Now in a world with microservices, you still might have a single entry point, you might have many entry points, and then on the back end there's potentially hundreds of processes, and end users may need to access any number of those services at any point in time. They might need to talk directly to them. They might be going through a UI. There could be a lot of different hops to fulfill a request across an application. And so this necessarily changes how we need to think about and approach application security. So today we're talking about a zero trust network model. The concept is pretty simple. Basically, by default, don't trust anything inside or outside. And you need to verify that every request is coming from a trusted source and is coming with the correct authorization and authentication before granting access to the underlying resources. And in reality, there might be things you want to do on the response end as well, which we might get to a little bit later. Now, why is it useful to think in terms of zero trust? From a risk perspective, as you start to develop microservice architectures, the surface area for that risk, the potential vectors of where attack vectors increases dramatically. End users also might need to access, there might be many more access points into the system depending on the different layout of your backend architecture. And traditionally, the traditional kind of approach to static security just doesn't really work effectively in a microservices world. So the first conceptual building block that we find useful in talking and thinking about zero trust networks is the API gateway. And essentially what this is a central control point for incoming and outgoing traffic between users and your application services. And at the gateway level, you can define rules around trust on a per service basis, as well as protocols in terms of what the shape of the request coming in need to look like, whether they need to be authenticated and encoded, whether we need to be using a particular root certificate that's known and trusted. And then we can generally shape traffic, monitor, and do verification as part of controlling access to the application. So our solution for the API gateway is Glue. It's a next generation API gateway and ingress controller built on Envoy proxy. So typically there's some proxy, typically you'd call this API gateway that's sitting in front of the application a proxy. Envoy is an open source, scalable, high performant proxy. It was designed at Lyft and has been used, seems to be one of the kind of the most commonly used proxy for both API gateway and service mesh use cases. Super lightweight. It's natively integrated with the cloud, and there's a ton of use cases around deploying Envoy and Kubernetes that have been well thought through. And there's a ton of features related to security and traffic shaping that really help you fine-tune the behavior and enforce kind of the rules that you're trying to enforce when it comes to zero trust. I should add here that it's also quite extensible, and as we'll get to a little bit later, we've actually extended Envoy with our own custom filters to even make, even expand that feature set of Envoy. Cool. So as I was preparing this, we were kind of listing out the different features that are relevant when we're talking about security and thinking about zero trust. The first two are obvious. There's a web application firewall is kind of the typical phrase used to talk about kind of protecting your system against requests that look suspicious coming in, and as well as potentially blocking responses depending on the nature of the responses. If it passes those checks, you still want to authenticate the requests. You want to ensure that even after authentication and you've properly identified where that request is coming from, it's also authorized to access the resources that you've kind of granted, that it's requesting access to. Generally, you want to be ensuring that there's mutual TLS across your entire application, as well as ensuring that you understand the certificate and the origin of the request coming in to the API gateway. And then there's some integrations that we've done with Glue to really help make these security workflows more robust around how to issue certificates, such as Let's Encrypt, and how to store secrets. As I was preparing demos for this webinar, it became pretty clear that we couldn't really cover everything here in just one session. So I'm going to call this part one of security. In particular, the things I want to focus on today are the web application firewall, authentication and authorization, and then integration with, and at the end, we'll talk about how Glue integrates with service meshes. Cool. So the first thing that we're going to focus on here is web application firewall, or WAF. So the web application firewall, the idea behind it is preventing harmful traffic from entering your environment. Now, this is an area of active research, and there's been a lot of work done in this area for many years. So we took the approach of let's leverage all of that great work done with the open source community. Particularly, we were looking at an implementation of this with the library mod security. And we wanted to incorporate mod security, the core rule set for mod security, into Envoy, as well as allow it to be highly configurable so that we could inspect and block traffic as necessary based on the rules that were defined, and applying that to all of your kind of outbound and inbound traffic. I should note here that WAF, or the web application firewall, is not something that's built into Envoy, and in fact, no other Envoy-backed API gateway has an out-of-the-box solution for this. This is a custom filter that we built, and we've extended. So if you deploy Enterprise Glue, you'll get it out of the box. Cool. So I'm going to shift gears and go over to a demo. And I'm going to use this cluster for all of the demos today. So just to set the stage a little bit, this is a view of my cluster from the command line. Here are all the pods running in the cluster. It's running in Google Kubernetes Engine, or GKE. And as you can see here, besides the system pods, I've deployed Glue into the Glue system namespace. And this is the latest enterprise Glue that ships with GlueCTL, as well as I've deployed here the Pet Clinic application for demo purposes. And if I go back to my browser, I've port forwarded the UI for Glue onto the just localhost 1234, just to show you. Here's the actual cluster. As you can see, I'm managing one Envoy here, and we'll dig into what that Envoy configuration is in a little bit. And I've got some upstreams, some of which were discovered, and I've also added an AWS upstream for the Pet Clinic application. And then in particular, I've got one virtual service here. I just called it default. The domain is *. And as you can see, it just has a single route, excuse me, to the pet clinic upstream on port 8080. From the command line, I ran gluectl proxy URL to get my gateway URL. I'll just show it here. And that because the only configuration here, the only virtual service I have, which is to match on all domains and match on / as a prefix, I would expect that every request going to that IP address hits the pet clinic application, and that's what you can see here. Cool. So the first thing I want to do is showcase WAF. And now there's a couple different ways I can configure WAF. So basically, Envoy lets you generally apply configuration on 3 levels. One is kind of at the across the entire proxy, or across the entire gateway, I should say. One is on the virtual service or virtual host in the Envoy language, and then finally on the route. And I'm going to show all 3 of those here. So the first thing I want to do is apply WAF on the gateway level. And actually, before I do, let me just curl and show what it looks like without WAF. So as you can see, I've kind of got the, this is my response. This is just the HTML that's being served from the pet clinic application. Now I'm going to apply a resource here that I have called default, or WAF gateway rather. Okay, and it looks like my gateway's been configured. Just to show you what that looks like, I'm going to go into the admin API UI and look at the configuration. We now show the raw configuration for all the resources that that we expose here, just to make it easy to look at what that YAML is. So as we can see here, I've added to my gateway YAML a plugin into the gateway section, which basically just wires up this WAF configuration. And I'm using a very simple rule set here, which just says if the user agent is scammer, then deny it with a 403. So I want to show that. So let me go do that curl again. I expect this to pass because I haven't changed my user agent. But now let's change the user agent and let's see what happens. And as you can see, mod security intervention occurred is the response that I get. So this is the WAF filter picking up on the fact that it's matched a rule that I had, which said deny things with the scammer user agent. And if I actually look at what the response code is, I can see it was a 403 forbidden, which is how I've configured it. I'm going to turn this off now. And in the UI, we now allow for editing of the YAML directly here, just for a convenience thing. So I'm going to make that change, remove that section that I added, apply it. And I expect that this should, as you can see, it immediately reverts that configuration and lets me curl this endpoint again. So now I want to do, now I want to just show other ways of applying this. So first, let me show it on the virtual service level. So I'm going to apply cool. And again, I'll show you in the UI what this looks like. So now I've added a virtual host plugin here, which configures WAF. Here, by putting the configuration here, what it means is for every route on this virtual host, I want to apply this configuration. And so in glue terminology, that would mean that every virtual service that provides configuration for this domain, every route across those virtual services would have this plugin configuration. With the introduction of a new feature that we added called delegate routes, it would also be the case that if you know, all of the routes that were delegated from this virtual service into a different route table would also have this configuration applied. This configuration is applied now, so let me just show as you can see, this curl request has been blocked again with the mod security intervention. And finally, I want to update the configuration and apply it just to the route. Cool. So, and if we look at that, so now my configuration has changed here. It used to be on a virtual hosts plugins section, and now it's on a route plugins. Just to kind of showcase this behavior, I've modified the virtual service to have two routes now. One is the more specific /owner prefix, which we've configured now to reject anything with the user agent scammer, and as well as a default route matching on prefix on the just slash as a prefix. So every other request that doesn't match the first /owner prefix would then hit this second route, and we'd expect that anything that goes to /owner is rejected, and then anything else is accepted or is passed through. I was having some trouble with my browser cache, but I think I should be able to show this here. So I've turned on a header called scammer. If I refresh here, it looks like the application is fine, as we'd expect. If I go to the vets page, it's fine. If I go to the owners page, now we can see mod security intervention has happened. Cool. So I'm going to do one more thing. Basically, I want to show just a different rule set. Mod security is highly configurable, and there's a core rule set that it ships, and even the core rule set can be customized. So I'm just going to apply one more configuration to this virtual service. And let's look at what that configuration is. So now I'm using the core rule set. I got rid of the other route. So this is, basically there's only one route that matches every prefix or every actual path. And now for basically this rule set is a little more verbose, and it's defining things like access logging. It's defining default behavior around blocking with a 403. And finally, this bottom section says allow things that come in with HTTP2. And so if I do one more curl, mod security intervention occurred, but it would occur anyway, even if I didn't pass that scammer header, because by default, I'm sending these curl requests with HTTP 1.1. Now let me just provide a flag to curl, HTTP2 prior knowledge. And as you can see, the curl actually returns correctly now. So that's it for the WAF demo. As I mentioned, this is highly configurable. I just wanted to showcase a few different ways in which we can demonstrate the behavior, as well as a few different places in which you can inject that configuration. But to find out more, there's a ton of information over here on at modsecurity.org. And if you're interested at all in protecting yourself against traffic coming in via web application firewall, I'd highly recommend checking out mod security and then looking at Glue as having extended Envoy to support the mod security library. Before I switch back to the slides, I'm going to go remove this configuration before I forget. All right, and just one last check. I would expect this to now pass again. Yep. Okay. So I'm going to go back to the slides for a minute. All right, so that's the first kind of major area that you're kind of you're thinking about in terms of protecting protecting against malicious incoming traffic. Now we want to authenticate that traffic, and then we potentially may want to do additional things like apply some authorization, apply some authorization, ensuring that the user that was authenticated actually has access to the particular resources or the particular endpoints that they're trying to access. Now, we recognize that our enterprise customers have a ton of different approaches to authentication and authorization. There's a bunch of different identity providers out there and a bunch of different implementations. Glue out of the box natively supports a few things. So for one, it supports authentication with OAuth. And for anyone that is kind of implementing the OpenID Connect protocol, we use Google OAuth internally to protect some of our internal services, ensuring that essentially people that are accessing them are part of our Google account. But some of our customers have other identity providers, such as Cognito. Some use LDAP, and Glue out of the box supports a lot of these integrations. We've also supported authenticating via other mechanisms, such as an API key, as well as kind of doing verification of JOTs that are coming in. Just to give a sense of the architecture here, so on the request, as a request comes in, after it hits the WAF filter and when Envoy and you've configured extra authentication, Envoy basically is configured to reach out to an external auth server that implements the API around authentication. And Enterprise Glue by default ships an implementation of that server called, and we just call it XDauth. And that's what has all these built-in implementations. XDauth, an alternative to using XDauth is you could write your own custom auth server, which is something that some of our customers have done. And it's just a larger maintenance burden, but it might make sense depending on the level, the technical level, as well as the willingness to take on more of a maintenance burden from our customers. We've also offered a middle ground. We've recently released a plugin framework. So if you want to essentially customize the behavior of Auth significantly more than, in a different way than what we provide out of the box, but you want a lower maintenance burden than maintaining your own custom server, we provide a mechanism to essentially build a Go-based plugin that can be dynamically loaded into the external auth server. And all you need to do is build it in a container that we provide, publish the built container to somewhere that's accessible to your Kubernetes cluster, and then when you go and deploy external auth with Glue, you just kind of reference that plugin as part of the deployment process, and we do the background work to mount that plugin into the place that external auth can pick it up. We've had customers that have wanted to basically implement custom authorization approaches, so we've worked with them to help develop their own custom plugins. So these are all options. I should note that our API allows for chaining of these, so it may make sense first to have an authentication step, which could even modify the request, adding a header to indicate what user or other kind of headers other information that helps with other checks, and then later in the chain also perform some kind of authorization. And that's a workflow that I want to showcase here as part of a demo. Cool. So just need to review my demo script here. So on this cluster, I've initialized Helm because I want to use Helm to install Dex, which is essentially an identity provider. And we're going to use it. The first thing that I want to do is set up a login screen and require people that are accessing my Pet Clinic application to first have to log in and identify themselves. So just waiting on this Helm install to happen. We can look at what the Dex values look like. Nope, it looks like that happened. But let me just show you the values. So here, as we've installed, when we installed Dex, we indicated where the callback URL is because Dex is going to help us perform OAuth. And the secret value, here we're just hard coding static accounts. There are two different users that have accounts and have access to the application, admin and user. And there's a secret value that Glue needs to know about, and then there's a password associated with each of these accounts. And for, as part of this example, it's just password. So Dex is installed. Now I need to actually go first create this secret. Okay, so now we've kind of encoded this secret into, we've encoded a secret that matches what Dex is expecting into our Glue configuration. And now we're going to apply another change to the virtual service. And let me go back and look at what that virtual service looks like now. So now we've added a virtual host plugin that creates an external auth configuration specifically for OAuth, and using kind of both the local host address and the callback that I mentioned. And we've configured it to use Dex as the issuer. So I need to do a few things, and then we should be able to see this in action. So first I need to port forward Dex. And then I also need to port forward, just for the demo here, I'm going to port forward the gateway proxy. Oops. Cool. So now if I log into localhost 8080, oop, made a mistake here. Oh, I think I actually need to do this. Okay, so I had a browser caching issue, but now I've opened in incognito. So now I've got my login screen. This is what Dex is providing. And as I mentioned before, as long as I provide an account that was in that static configuration that I passed to Dex at install time, I should be able to log in. So my one of the accounts was admin@example.com with the password, and now I can access the Pet Clinic application. I want to show that I can access it with the other account too. So I'm going to log back in, this time with user example.com. And I can log in with user as well. So now we've established on our virtual service, let me go back. Just to review, we've added this OAuth configuration to the virtual service, and now we've performed this authentication check as part of accessing the underlying resource. In this case, it's the Pet Clinic application, any path for that application. And in this case, it's any domain, which we've just port forwarded to localhost 8080. But now I want to do something different. I actually want to restrict access of certain portions of this application to a user. So in addition to just performing this login function, I want to demonstrate that depending on which user logged in, I can modify the underlying access. And let's just, for the purpose of demonstrating this, let's say that this find owners section of the application will be restricted only to admins, whereas everything else can be accessed by both admins and the main user. So let me show you first the virtual service. I've called this default with JOT and OPA. So here we're using another built-in feature of Glue's external auth server, which is OAuth authorization, OPA authorization. And essentially, we're enforcing that. Essentially what we're doing is we're going to read rules out of a module called allow JOT that's in a config map, and based on those rules, we'll decide in this step if the user that got authenticated in the first step actually has access to the resource that's being requested. And to see what those rules are, let's look at allow jot. They use a language called Rego, and it essentially is, this is the definition of it, where the default rule here is access is denied, but there is an allow rule for admin to be able to access everything, and then an allow rule for user to be able to access everything except everything that does not start with /owners. And so this is the way in which we're going to add an authorization for admins to access owners, but for users to be denied. So there's two steps I need to do to enable this. The first is to create a config map that has this configuration in it. And then I just need to update my virtual service. I showed you what it looks like. Now I'm going to just apply that. Oops. Okay, it should be configured now, and let's give it a shot. So let me log in. Oh, I need to go back and do the port forwarding. Looks like my proxy is still port forwarded, so I should now be able to get to a login screen. Okay, and we're going to log in again as admin first to ensure that we still have access to everything. Great, so it looks like every part of this application is still accessible. Now let's log in as the user. And now we can see that the particular owners section of this application, this user is not authorized to access that. Great, so that is the second part of my demo here, showcasing essentially that with Glue, there's a lot of configuration options for doing authentication and authorization. I've shown you a few of them here today. First, I showed an authentication step that uses DEX as an identity provider and as a login mechanism. And it does OAuth against, in this case, my static configuration. And through that mechanism, I was able to authenticate both the user and the admin that I logged in as. And then I was able to add a subsequent step, which was to do additional authorization of the specific resource being accessed, whereby if it was admin trying to access it, they would be allowed, but if it was user, it would be disallowed. Great. As I mentioned before, there's a lot of other implementations of Auth, plus a few other mechanisms to customize it. And I'm sure that we'll have a lot more to say about this in a future update. So just to recap what we've talked about so far, first we looked at WAF, then we looked at authentication and authorization. Generally, the examples I've shown have just used the kind of unprotected HTTP port, but you could imagine setting up root certificates and ensuring that all the traffic coming in, first, what the proxy could first do is terminate SSL and ensure that all the traffic coming in also has a trusted root certificate. And we've done this internally on some of our clusters as in an integration point with Let's Encrypt to make sure that we're issuing and rotating certificates to access, and that users that are accessing our requests that are hitting our internal instances behind Glue are coming from trusted sources. Now, outside of just a gateway use case, there's a lot more that you can do with Glue and with other integrations. In particular, what we've talked about today so far is essentially north-south traffic. It's essentially all the requests coming in to your application go through a central gateway, and then the gateway farms out those requests to the underlying service or resource that they should go to. But now, once a request is in, imagine that for a service to satisfy that request, it needs to reach out to other services. And typically, as we've started to see over the last few years, people have started to think about this traffic, which we call east-west traffic, as another place in which we need to be thinking about security and finding some mechanism to ensure security in a zero trust network. And usually the implementation of this is deploying a service mesh. So one example of a service mesh is Istio, which has its own control plane that's responsible for deploying, primarily responsible for deploying sidecar proxies next to every container, every pod in your application, or every process, I should say. The Istio control plane can reconfigure those proxies, and when a service is talking to another service inside of that application, Istio configures the networking such that the service thinks it's talking directly to the other service, but in fact, it's talking to the sidecar, and then the traffic from one service to another is all happening from sidecar to sidecar. And by doing it that way, we can reconfigure the proxy or set up certain features on the proxy to ensure that the traffic is encrypted. We can ensure that the traffic is shaped in different ways. We can do things like logging and observability very easily without having to go redeploy your application or update the code at all. But what if you want to do both? So what if you want to do both, like you set up a gateway that does authorization and authentication and handles your north-south traffic into your application, but you're in a zero trust network, you want to ensure that you've got mutual TLS across all of your east-west traffic across your application. And you want your gateway, ultimately what this boils down to is you need your gateway and your service mesh to have compatible certificates. And I'm going to demonstrate how we can easily configure Glue to talk to an application that's running with Istio, and the Glue proxy can talk directly to the sidecars or directly to the services that are deployed with Istio. Okay, so first let me clear out all the state from my old demo, and let me just delete my old virtual service. Cool, so first I'm going to make sure I have admin. Now I'm going to go and install Istio. Oops, I forgot to make a namespace. So Istio install has two steps. The first is deploying all the CRDs and other static things that don't change across upgrades, and then and we can ensure that all those, looks like not all the CRDs are there yet. Now they are. Istio has 23 CRDs that it ships with. And then we can deploy a demo of, basically we're going to deploy a manifest called Istio demo auth. This is just a convenience manifest that was rendered with the underlying Helm chart to showcase some of these auth features. There's a lot of resources that get created when Istio is installed, so it finished applying those, and now we need to wait for all the pods to get up and running. This is a good time to mention, I've essentially created a few different workflows to try out these different security features. We'll be publishing both a video of these demos as well as documentation for how to run through these yourself, which can be a very useful way to actually get a better mental model for how these features work. Here we can see it looks like a number of the Istio pods are up and running, not quite all of them yet, so still going to wait. Let me actually see now, where are we at? Looks like just a couple more containers need to be created. So to look ahead, what we're going to do is first set up the default namespace to be injected with Istio. What that does is tells Istio that when new deployments get added, or when new pods get created in that namespace, put the Istio sidecar inside of them. I think that's all of the containers. Let me just make sure. Yeah, so now everything is running or it's completed. So we're ready to go. So first I'll do that command to label the default namespace. And now I'm going to deploy bookinfo, the canonical Istio application, into that namespace. So it created a bunch of deployments. The bookinfo application is essentially first a product page, and then the product page, to populate data on the product page, it accesses a few underlying services for details about the product, ratings, and reviews about the product. And it also ships with a few different versions of the review service if you're kind of trying to play around with a traffic shifting type of scenario. For our purposes here today, we're just looking at security. By deploying the auth demo, I've deployed basically I've deployed Istio and set up the injector so that traffic is enforcing, the proxies are enforcing mutual TLS across the application. And we can do a check on that using the built-in Istio tool. Okay, so now it looks like all the pods that I've added, as you can see, there are 2 containers in each of the ones I just deployed, which indicates that not just both the bookinfo container as well as the sidecar proxy are deployed in them. Oops. So now I want to just show a few things to indicate, just to prove that we've actually got TLS set up. So this is the output of Istio's built-in Istio CTL tool that tells you, essentially performs a check to indicate, are you talking with MTLS between the pod that you've provided and everything else in the system? And it looks like the answer is yes here. But we can prove it. So let's first access the application directly. And I'm just expecting this curl to return a response as part of the, to essentially pull out a section of the HTML that got responded. So if we directly hit that container without bypassing the proxy, we should be able to get a response. Now let's go through the proxy. And we're getting termination errors now on the response here. And if we pass the -K option, we're still going to get some termination errors here. Essentially, we don't have the right certs to actually fulfill this request. And finally, if I do kind of make the request while also providing the certs, I can get a 200. Great. So this proves that once you're inside of the network, accessing the application, traffic is flowing with MTLS. But now I want to actually add a route through my gateway proxy. So let me do that. Okay, so here I've added a route. I've called it product. I've added a virtual service called product page, maps to the default domain. Because I deleted my old virtual service, this is the only one I have. It just has the one route to /, and it's just routing to product page. And I would expect that this is accepted now. It is. So now I want to show, I want to curl. And it looks like I'm not able to curl. That's expected because I haven't really done anything related to setting up certificates with Glue. So that's the final step here. I want to essentially ensure that Glue is routing to an upstream that it knows to use SSL with, as well as updating the proxy to have the correct certificates. So let's look at what those look like first. So this is an updated version of the upstream, Glue's representation of the destination for the product page service. And what I currently have, just to compare, this is called So what I currently have here is just the destination, which is a kube service, but there's nothing about the SSL configuration. And as I showed before, what I'm going to add now is the actual SSL config telling Glue that when talking to this upstream, there are certificates. So let me first apply this. And then the other part of the configuration that I need to do is go update the proxies deployment to also have the correct certificates. So let's just look at what that is. And what we've added here are we've mounted a volume that contains the Istio certs. And so now it should be, after kind of traffic goes through the proxy, it should be re-enabling SSL with the correct certs that are compatible with the sidecars for Istio. Now, I've updated the deployment, so Kubernetes is going to do a rolling upgrade here. It looks like the new proxy is there. And as you can see, I can now curl and get a response on this product page, and I can actually should just be able to show it in my browser. Great. So this is the book info application, but now we've done it. We've accessed this in a way where we're hitting kind of a proxy, our API gateway at the front door. So the north-south traffic, the traffic from me into the application, is being guarded by that proxy. And then that proxy is using SSL with compatible certificates with Istio to ensure that all the communication within the application, because this is a zero trust network, is actually encrypted with SSL. All right. So I'm going to go back to presentation. So that's it for the demos. I just wanted to showcase, just to kind of summarize one more time, when you're thinking about zero trust networks, you kind of want to follow the request path and ensure that every step along the way you've thought about all the risk vectors and ensured that we're properly guarded. And so that starts with, is the traffic coming in encrypted with SSL with a known certificate? If so, the proxy at the front door handling north-south traffic, our Glue gateway, should be able to terminate SSL and then perform a variety of functions. Should perform WAF to ensure that the traffic isn't suspicious, both on the request and the response path. It should be able to then go apply an authorization and authentication set of filters, or a filter that can perform one or more sets of steps around authentication and authorization of the request. And then finally, as you're continuing to propagate traffic throughout the system, throughout the application, you may be leveraging a service mesh to do MTLS, and Glue can seamlessly integrate with that service mesh, avoiding the need for any extra hops. The Glue proxy can talk directly to the sidecars of the application. Just to summarize kind of the Glue release model, there's a few different flavors of Glue. So we have open source Glue, and then we have enterprise Glue. Some of the functionality that I've demonstrated here, such as working with SSL, is totally compatible with open source Glue. There's no extra filters that you need in Envoy to enable that, which means that if you wanted to use open source Glue as your gateway in front of an Istio service mesh application, you can do that today. But then enterprise Glue packs in a bunch of extra features to really help with security in some of the zero trust networks. So the WAF filter is a novel filter that we added. We've extended Envoy with that filter. You get it for free with enterprise Glue. You get it out of the box with enterprise Glue. And then in addition to that, we've got a pretty robust external auth service with a bunch of different implementations, as well as an extensible plugin framework, and finally the ability to plug in your own custom server altogether. And with that, that wraps up at least part one, I'd say, of security. There are a lot of other topics I didn't get to just for the purpose of time. In particular, once you've gotten past this stuff, there's a number of other things you might want to do, such as observe and monitor, measure the actual cost of traffic. So how much time does, how much latency is incurred by actually running through the authorization steps. There are then potential ways that you want to work with how you're deploying these things to optimize that performance. So we enable running external auth, for instance, as a sidecar next to Envoy directly to avoid the hop that you would normally take as the request is going from Envoy out to the authentication service. That and a number of other topics I look forward to talking through in more detail at a future webinar. But for now, I think that wraps this up, and we can shift into questions.
All right, so folks, please type your questions into the Q&A window or the chat. Also, if there was something that that Rick just mentioned but did not demo today, and you'd like to see more, you'd like to see that topic in more detail, go ahead and actually put that in the chat as well, so we can kind of capture that and use that for a subsequent topic. For those of you actually, there's some links right there to learn more. The solo.io /GlueE, that is the product page that's going to talk about Glue in more detail. We do have a trial for the Glue Enterprise. Glue open source can be downloaded directly from, there's instructions directly from the documentation. And then if you want to carry on, start a discussion or ask additional questions after this session, hop into our Slack community, and then we've got a channel for both Glue and Glue Enterprise. I'm seeing a couple of questions here, Rick. You know, you talked about, they're asking, does WAF, you mentioned quickly that WAF handling traffic both ways. The way in, you know, for WAF kind of to inspect and block the traffic coming into the cluster totally makes sense. What does it do to the returning traffic?
Yeah, so this is a good question. It's come up with some of our customers. I can share what WAF does and then what it doesn't do. So what WAF essentially does is provide a yes/no answer based on a set of pre-configured or custom rules, whether the traffic should be allowed through. And otherwise, as you saw in my examples, it would the mod security library would intervene and block that traffic. And so those rules can be applied both to the request and the response itself. In the case where a response is blocked by the set of rules, it just replaces the body of the response, indicating that the request is blocked. So that's what WAF does do. In terms of what it doesn't do, we've had customers explore and ask about things related to data loss prevention. So let's say I don't want to just reject requests, but I do want to potentially mask data as it's leaving the proxy to ensure that sensitive information, maybe personally identifying information, doesn't leak out. WAF doesn't do that out of the box, though, as I mentioned, we are working with customers interested in that, and I think we'll have more to say about those kinds of use cases at a later date. But yeah, regarding WAF, the short answer is it performs the same function as it does on the requests, on the response, and that is all configurable.
Cool. Got another question here, and it's can Glue replace the sidecar Envoy proxy of an Istio service mesh? And I think this is a really good question because we do, with all these proxies everywhere, as we look at, you know, from API gateways, microservices, and mesh, this is a pretty common question. Rick, do you want to comment, answer that with kind of an explanation on the architecture?
Sure, yeah, it's a great question, and it comes up a lot. So there are things that we're trying to do and then things that we're not trying to do. What we're not trying to do is really replace Istio. Glue isn't a service mesh. It's really an API gateway. That being said, there may be things, what we have explored with customers. Essentially, for Istio, it deploys Envoy as well as Glue and Istio both deploy Envoy, and they both deploy Envoy with a slightly different set of filters. And we've explored resolving those into a single Envoy image so that we can leverage the configuration across both the API gateway and across the sidecar proxies. We've also tried to ensure that we would just work seamlessly with the sidecars, as I mentioned, as I demonstrated in this demo today, so that ultimately Glue could replace, in the Istio kind of terminology, the ingress gateway. But yeah, I wouldn't say like we're completely trying to replace the sidecars altogether or become the control plane for those Istio sidecars. I think that's the kind of bread and butter of Istio, and we're not really trying to be the mesh at this point. One other thing worth noting is we have gotten we've heard concern from customers who are exploring Istio and exploring other technologies about just the latency and ultimately the cost of some of the implementation of authentication, and just due to some of the architectural decisions made in early Istio. I will say that Istio has gotten a lot better with that stuff, but we have found it to be very useful to have Glue at the front door, performing like your general kind of authentication and authorization, and then leverage the other features of Istio proper. So hopefully that answers the question. It's in short, like we're not completely trying to replace Istio. I think we're trying to really make it work seamlessly, and in cases where you need to leverage kind of filters in both, we definitely have explored paths forward to make that a reality.
And it's actually a good shout out for what Rick talked about today was functionality within the API gateway. But the other aspect of what Solo does is works with service mesh and actually using the kind of the Envoy proxy sidecar architecture to provide additional, do more interesting things and provide functionality into the mesh. So if you're interested in some of that, you can hit me up on the Slack, and I can send you links to some of those demos. Rick, we've got a question here. You mentioned it a little briefly about latency as a topic, but question around external auth and if there's latency there for the user experience because it's hopping out.
Sure. Yeah. So we often get questions about what network hops are incurred on the request path. What's the latency of those hops? And like generally how to optimize the performance around this kind of stuff. So the way Envoy is built, it does reach out to an external authentication service to perform that XDOT check. So it will be one hop to that other service. Inside of that check implementation, it can perform all of your both your it can perform all the different steps. So in the case that we laid out, it would be a single hop over to the external auth server to do your kind of authentication and resolve who the user is, and then to also perform the authorization check to ensure that they have access to the requested resource. But we still have people concerned. So it shouldn't be a concern that we're introducing several extra hops, but even just one is a concern, and especially when it's possible that the implementation of, let's say, authentication needs to reach out to an identity provider or some backing store to access a database of known users. And so, there's no getting around the fact that the implementation inside of the external auth server needs to know how to resolve that request. We've found that certain customers have managed to achieve this with caching and some time to live on the tokens, and there are a variety of approaches we've kind of worked with customers to get that out of the request path. Another thing to say there is we've found significant performance improvements running the external auth service as a sidecar to the Envoy proxy itself. So, like specifically what this means is you've got your Envoy deployed somewhere that's sitting at your edge, and next to that, communicating over a Unix domain socket is the external auth server. And so that kind of cuts out the overhead, which of potentially the network or the TCP protocol, And we've seen significant improvements in kind of overall latency when deploying it in that way. And that might be, if we need to make further, if that ends up becoming a concern in your architecture, it's a great place to explore optimizing. But that's kind of I'd say that usually addresses. We found that even in the case where there is a network hop, it's often been sufficient. We've gotten, we're talking sub 10 millisecond, usually significantly less than that, depending on the complexity of the implementation of the external auth protocol, essentially, of the actual auth mechanism. And yeah, that hop can be improved either through caching or through clever deployment of the service.
Cool. Looks like that's it for the questions, and I want to thank everyone for sticking around past the hour. Thanks, Rick, for the session today. And folks, remember, hop into the Slack community in case there's a question that you're thinking about that you haven't asked yet, or if there's a specific topic that you'd want to dig in more related to security. We'll get this recording out shortly, and we'll see you soon at the next one. Thanks.
Thanks.
Bye.